Hello everybody, and welcome back to the Regular Expression Python series. In this lesson, we're going to be taking a look at regex character classes. Now these character classes are just going to make it a little bit easier to identify specific patterns within our string or text that we're going to be working with. At the very bottom, you should actually recognize some of these patterns, like with these brackets A through Z or A through Z. This is actually very similar to using something like the \D. And so there are ways you can shorten and make this a little bit easier, as well as look for certain unique things. Now, one thing to mention really quickly is there is one on here, and I just could not find a good visual for this, but there is another one on here called \W, which stands for boundary. We'll also look at that in this lesson, even though I couldn't find anywhere that talked about it. But if we look really quickly, we have \D, which matches digits. Usually the capital letter is the opposite of that. So then we have D, which matches any non-digit. \W matches any alphanumeric character, and then the \W or capital W is the opposite of that. \S stands for matching white space, and then capital S is non-white space. So we're going to be taking a look at all of these and how we can use them. Let's scroll right down here. And let's start off by creating our quote or our string. We'll call this quote in this lesson. And we can say, my name is Neo. My phone, that's how you spell phone. My phone number is random numbers. There we go. And that's one too many in here. Go. And then we'll say my email is thematrixman@gmail.com. Neo uses Gmail, I'm pretty sure. So let's go ahead and create this. And let's see how we can use these character classes. So what we're going to do is re.findAll. And again, we're using our quote, so we're just going to specify that. Now let's start off with probably the easiest or the simplest one, which is \D. This stands for digits, so we're looking for the digits, which are all right here. Let's go ahead and run this. And of course, I need to actually import regular expression. So let me put this up here. We'll import regular expression, run our quote again. There we go. So now we have all of our numbers all broken out. Now, what if I wanted to look for more digits? I could use these squiggly brackets, and I could say I want to look for 3 digits. Now let's run this. Now we're grouping the digits based off of 3. We're looking for 3 digits in a row. So now we have 534 right here, 342 right here, but then this has 1, 2, 3, 4. There's 4 digits here, but it only takes the first 3. This would be extremely similar if we did like this, and we said 0-9. And if we run this, we get this exact same output, but this one's just a little bit longer, and we can go ahead and specify other things in this as well. I personally have found that when I'm working with digits, I'm looking for all the numbers, so I tend to find myself using this one quite a bit more than using the brackets with 0-9 in it. But if we took this very similarly, and instead of the lowercase d, we did a capital D. If we run this, it's going to take everything that is not a number. So all of the non-numeric numbers, even the periods and the spaces and all that stuff. And the dashes right here in between the numbers. So it's taking literally every single thing except for the numbers. It's the opposite of the lowercase d. Now let's copy this, and we're just going to go right down here. And we're going to take a look at \W. And again, this is our alphanumeric characters. So if we go down here, say re.findAll, and we're say comma quote, and when we do a \W, we're going to almost get everything, except we're really taking out all the fillers. All of the periods, all of the white spaces, all of the dashes, all of these things are taken out. Now, what if we change this to a capital W? We'll get the exact opposite. So now we're taking all of those filler things. We're taking all the spaces, all the dashes, the periods, the @ signs. We're taking all of those things, which is the exact opposite of what we get with the lowercase w. Now let's go ahead and copy this quote. We'll come down once again. Now we're going to be taking a look at the \S. Now, lowercase s is going to match any white space characters like spaces, tabs, new lines, or things like that. So if I say re.findAll, comma quote, we're just going to do \S. Keep it really, really simple. So \S. Now it's going to take the white spaces, which is spaces, tabs, or new lines. It's not going to take things like periods. It's not going to take things like dashes or @ signs. It's just looking mostly at white space. Now, if we do a capital S, and just like this, we're looking at everything but the white space. Now it's every single character except things like spaces or tabs or enter, which is the \n or new line. So now it's the exact opposite. That's all the \, lowercase s, and capital S. That's all that is. Now, the next one that we're going to take a look at was going to be \b, which is boundary. And I think that one's really interesting. But before I do that, I am going to show you two that I almost never ever use, almost ever. But I'm going to show it to you anyways, just so that, I feel like I've showed you everything. I'm not withholding things from you. And what we're going to do is re.findAll, and actually put right here. We'll look at the \a and \z. So we're doing re.findAll. We'll do comma quote. And what we're going to do, we're going to use our quotes and say \a. \a and z are kind of like a caret and a $sign in the meta characters. You're looking at the beginning and the end of a string. Now, if I just run this, I'm going to get nothing. But what if I looked for, I did a bracket and I did like A to Z, or A-Z, A-Z, and let's run this. Now I was able to find the very first character because we were looking at capital M. So we found that. But if we did the Z, now that's not going to work. Much like the $sign, this needs to go at the end now if we want to look at the end. So let's run this. And now we found the M at the very end. These two I almost never use. Unlike when you're using a caret and a $sign, I feel like the A and the Z are just pretty much, they're redundant. They do the exact same thing as something else in the exact same way, except you use \Z instead of just doing something like a $sign, which gives you the same output. And the $sign I think is just easier to spot, easier to visualize. And whenever I use it in my actual job, that's how everyone else did it as well. No one ever used those \Z's or A's. So again, just wanted to show it to you, but not something that I really actually use, if I'm being honest. Now let's go on to B, which stands for boundary. Now for this one, we are going to actually use a different quote. We'll keep it on the similar theme. We'll say, I love the matrix. Is matrix love a word? ? Now this makes absolutely no sense, but it'll make sense in just a second. So let's go ahead and bring this down. And we're going to get rid of all of this. And if we wanted to search for just the matrix, we can do that. Let's go ahead and search, and we're able to find both. But we can use these lowercase b's as boundary points. So we're going to say \b and then \b. So we're looking for a boundary on the left-hand side and a boundary on the right-hand side, kind of like white space. And what we can do is look for that. We're not getting an output. Let's actually, R right here. There we go. So this represents raw string. So now we're looking at a raw string literal. That's what this is called. I'm not going to go into what all that means, but basically it'll change this from just a regular string into a raw string literal, which sometimes definitely can matter in regular expression. And we'll look at that in the next lesson. But just wanted to show that to you. So putting that quick fix. But we're looking at boundaries. So we have a boundary on the left-hand side. We have a boundary on the right-hand side. It's only going to pick up this matrix because this has LOVE on the right-hand side, has a boundary on the left. It does not have a boundary on the right. Now, if I get rid of this second boundary right here, and I run this, we'll get both because this matrix has a boundary on the left and this matrix also has a boundary on the left. Now, what if I wanted to use the capital B? Let's do the capital B. Let's run this. Neither of these work. And that's because we're looking for a non-boundary. And so we're looking for matrix, but on the left-hand side, we have no boundary. And that could either be a period or it could be another letter. So if we just got rid of this right here, we're looking for atrix, but with a non-boundary, which should be that M. We should be able to find both of those. So those are our character classes, and the meta characters and the character classes separately, when you're learning them in two different lessons, they may not fully 100% make sense. And I try to do my best to visually see it. But where it really shines is when you're looking for actual patterns. So in the next lesson, we'll be looking at use cases. So real use cases where you can use all these things in combination to specify very specific patterns. And that's really the power of regular expression. So again, this is the end of the character classes lesson. Thank you so much for watching. If you like this video, be sure to like and subscribe below, and I'll see you in the next lesson.